Let's take a moment and thank our sponsor, Text Control. There's always something new from Text Control. As a developer, do you need to integrate PDF generation, document editing, or electronic signatures into your ASP.NET Core or Angular applications? Or maybe you want to learn more about the differences between electronic and digital signatures. Text Control is offering a free consulting service to educate you about digital document processing and how Text Control products can help you add these features to your applications. You just go to textcontrol.com/contact and you can request your free personal consultation. How cool is that? Textcontrol.com/contact and you can request a free personal consultation from our friends at Text Control. Hi, I'm Scott Hansel, and this is another episode of Hansel Minutes. Today I'm chatting with Jason C McDonald, also known as CodeMouse92. He's the author of Dead Simple Python, which I am lucky enough to have read and enjoyed. And we're going to have a chat today on Hansel Minutes. How are you, sir?
I'm doing very well. How are you?
I'm pretty good. I have to say, though, I want to start out. I'm going to give you a hard time. I was excited to read a book called Dead Simple Python. I'm thinking to myself, this is great. I'm going to do it in a weekend. It's not going to be a problem. And then somewhere around page 690, I started to realize that it's dead simple, but it's also 700 pages long. So I'm going to challenge you. Why?
Yeah, I got the same question from Naomi Cedar when she was about to write the foreword. Told her about the book. She's like, dead simple concurrency, excuse me. But it's the same reason why we say things are obvious in Python. So Python, if you're familiar with the poem The Zen of Python by Tim Peters, which is kind of has become our tongue-in-cheek guiding star of the language, as much as anything could be a guiding star in a language named after Monty Python. The idea of one obvious way has tripped a lot of people up because you're looking at a problem and you go, I don't see an obvious solution. But the point is not obvious going forward. It's obvious retrospectively, in that that's what the phrase means. Unless you're Dutch, unless you really understand the language, you're not necessarily going to know that obvious way looking forward. But once you've seen the solution, you look back and go, oh, I can't think of any better way to do it. And so Dead Simple Python is the same thing. Looking forward, some of these topics that I cover are sometimes a little bit intimidating, like concurrency or metaclasses or what have you. But when you get through it and you look backward, the hope is you can go, oh yeah, that's actually pretty dead simple.
I like that. Yeah, it's great that you had Dr. Naomi Cedar, who's on the Python Foundation, write that forward. And she points that out where she's saying it's not dead simple like, oh, it's dumbed down. It's like, oh, I get it. So it sounds like that was your intent with this book, was to make everyone go, that seemed really hard, but now I get it.
Exactly. It's that click. And that I've always enjoyed not only finding that click myself, but also helping other people find it.
Mm-hmm. And then she points out that there is a wealth of information here. It seems like you decided how long it would be because you just wrote until you were finished. And you know what I mean? Like, you're like, well, you must have had you couldn't have planned 800 pages, 700 pages. You must have said, well, I'll come up with my chapters and then I'll just write until it's been explained. And then that's when you decided when it's out of pages?
Yeah, basically. I mean, I realized about 2/3 of the way through the writing process that the original estimate, which I had told everybody at No Starch not to hinge anything on, you'll still see some descriptions around the internet saying under 400 pages. And when I first saw that from the marketing department, I'm like, I did tell you not to pin on that because it's going to be way past 400 pages. But I didn't know how long it was going to be. And once I realized it was definitely far past that point, I also realized somewhere around there that as I was going through the documentation for what was probably by that point the 17th time, I looked at the glossary and I decided to just grab a piece of paper and go through the glossary and just do a checklist of how many concepts did I cover. I was more or less curious, and I discovered that I had covered about 98% of them. And so I just went, no, what the heck? And I covered the other 2% and brought the whole book up to where it at least defines in some sort of working capacity every single concept that's defined by the documentation, which is definitely a massive undertaking. And had I realized what I was getting myself into at the beginning of the process, I might not have done it. But such is the retrospective of all grade projects, I guess.
One of the things that I like exploring when I have folks on my podcast is that everyone has some small flavor of, well, most people have a small flavor of imposter syndrome. So surely when you decided to tackle something like Python, you must have said to yourself, well, why me? Why not Guido? Why not some of these PhDs on the software foundation? Like, why does and no disrespect, why does a random person decide to go and write a book of this scope? And did you ever doubt yourself on page 500?
Oh, I doubted myself frequently throughout the book, but the whole reason I picked it up, I actually have to go back to the genesis of this, was not a book at all, but an article series on dev.to. And I just started writing these articles because I've been hanging out in the Python IRC channel basically since my first Hello World in the language. And I noticed over years of being in that channel that the same questions kept coming up over and over. And we'd kind of meagerly, like, weekly point to the documentation and go, well, that's okay, I guess. People would go, great, I read that 7 times already. It doesn't make sense still. And so I just realized no one's written some of this stuff down. Like, the information's there, but it's spread to the 4 corners of the earth. So I thought, well, I've always had a knack for being able to explain complex things as like a tutor or a mentor. So maybe I should write some of the stuff down. So I started, and I picked on some of my friends in the IRC channel, who typically the ones who would disagree with me the most. And I said, here, edit this. Because I knew if they liked it, then it was accurate. So I started writing this. I just thought, it'll just be a tool. Someone will read it. More than someone. I get about halfway through the article series, I get an IRC message. Someone said, did you see the Android newsfeed? I'm like, no, why? He said, you're in it. I'm like, what? It was trending. My article series was trending, which I did not expect. So that was around the time I began thinking, I may be sitting on a book. And just realizing that up to that point, everyone who sat down to write a Python book, there were a lot of people that had done it, but there were exactly 2 kinds of Python books you could get. There was, here's how to write Python. You've never coded before, so we're going to start by explaining variables, boys and girls. The other kind of book was, today we're going to be programming an Arduino Raspberry Pi to do machine learning image recognition to separate pictures of cats from pictures of turnips running on a potato battery in your grandmother's basement. And there was nothing in between the two. And so I thought, we need an introduction to the language that just doesn't bog down with Programming 101. There's already amazing books that introduce it. Al Sweigert's books come to mind, or Python Crash Course. Those are incredible introductions to the language for first timers. But if you already know how to code, you want to get past that stuff and you want to get into the deeper mechanics. No one had really attempted that as far as I could tell. So I thought, what the heck? I mean, I'll be the first. I may not be the best, but it's something. And it turned out better than I expected.
That's great. One of the analogies that you kind of use throughout it and in the introduction, of course, is this idea of a programming language versus a human language, human linguistics. And you talk about being idiomatic. What does that mean to you? I know what I think about it, but I want to know you define that. When someone is speaking a language idiomatically versus just maybe doing a machine translation.
Yeah, well, my academic background is in communication. And in case anyone's wondering, I didn't finish college because I realized partway into it that I was spending a lot of money for a degree I didn't need for my career path. But I did take a lot of communication classes and I loved it. So my focus has always been on actually human communication first, and then computer languages secondarily. And I think that's flavored things. So when I'm talking about idiomatic, and I do talk a lot about speaking Python natively, as it were. Spanish is a good example that comes to mind in terms of human languages. Like, I'm learning Spanish on Duolingo, and I'm doing okay. I've got like a 2-year streak or whatever. But when I'm talking to my adopted brother Jaime, who lives in Mexico, or when I'm talking to my dear friend Gerard, who lives in the Dominican Republic, their Spanish is so fundamentally different than what I'm learning on Duolingo. Duolingo teaches you the mechanics and the vocabulary, but you still wind up stringing together sentences in an English form. And that's where a lot of people trip over language differences, because you think the thought in English and you try to translate that into Spanish, whereas Spanish has all of these really colorful phrases and ways of explaining things that literally do not make sense in English. There is no translation for it. And if you're going to be able to be an effective communicator in, say, Mexico or in the Dominican Republic, you have to understand how those phrases work, which means you have to understand the mechanics of the language as well as the culture. So in the same way with Python, you have to understand what sets Python apart, what makes it different from other languages, and the culture that produced it, in order to really understand and be able to craft these quote unquote obvious solutions. And I think that's true of any language. I do like to talk a lot about how every language has its thing. Every language has one thing that has been prioritized above all else. For Python, it's introspection. For something like C#, it's inversion of control. For Ruby, it's lack of parentheses. Totally serious on that. For Rust, it's borrowing. Like, there's one concept that rules them all. And once you grasp that concept and the motivations behind it, everything else falls into place.
I think it's fun that you brought up Dominican Spanish, because I have my own flavor of learned Spanish in school and Chipotle Spanish and, effective food ordering Spanish. But then you go to the DR and then you have to, learn que es lo que es. And you're just like, what does that mean? Oh, it just means what it is, what it is. And you're absolutely right. It doesn't translate. You can try to make it translate, but it doesn't. So you just have to have it roll over you. Now, you say in the example of Python, an established developer picks up Python as a second or third language. They may be baked already, and their word choice, their keyword choices, and the order in which that they do things is going to be like, for example, idiomatically C. I happen to be a curly brace language person, and I suspect that a number of you could probably read my Python and go, this guy's a C programmer. I can smell it. I don't know why, but I can just see, no pun intended, the way that I've gone and organized it, right? And you actually call out that Dead Simple Python is a guidebook for those that have already become somewhat baked in another language, and you're trying to get them to unlearn stuff.
Exactly, yes, because what you're doing is, instead of just memorizing, see, the reason we can learn something like que lo que in Dominican is because you're not starting from the translation angle. You're starting from the angle of, here's what this is communicating. Here's why we're communicating it like this. And it starts to make a little more sense, and then it settles into the brain. So with Dead Simple Python, I start from what I think of. I never called it this in the book, regrettably, but what I think of is the sugar-free example. Like, I get all the syntactic sugar out of the way, and it's like, this is the, if I removed all the fancy features of Python and it was just, bare logic, but still ran, here's what it would look like. Now let's add a layer on top of that and add a layer on top of that. So by the time you get to the for loop, for example, you understand all of the interactions with the iter and next functions and how iterations functioning in Python. And because you approach it like that, you can think of a for loop in Python in a very different way than you would think of a for loop in C, because there's a different mechanism driving it. So you're actually breaking the association between the two. You're interrupting the pattern matching, and you are allowing the person to learn that technique for itself instead of in light of the language that they already know.
This episode of Hansel Minutes is brought to you by User Interviews. User Interviews connects researchers with quality participants. Participants earn money for their feedback on real products. There is high demand for software developers and engineers to provide feedback on products being created for developers. It's free to sign up, and most studies are less than an hour and pay over $60. Some studies pay several $100s for a one-on-one interview. You can share your opinions with top brands, Adobe, Intuit, Spotify, Amazon, and many more. Are you ready to earn extra income from sharing your expert opinion? Head over to userinterviews.com/hello to sign up and participate today. That's userinterviews.com/hello. You start right off also breaking a number of myths. And, whenever if someone starts listing out myths, I'm like, oh shoot, I believed that. And then it's like myth after myth after myth. Like, yeah, oh, crap, I believed that one too. You call out Python's just a scripting language. Python is slow. It can't be compiled. Or, you can't use it for anything other than small projects. And you just kind of break them down one at a time. However, myths usually exist for a reason. Where did these myths come from, and why is it important to bust them away?
I would say a lot of the myths regarding Python hinge on kind of the father myth of all of them is that Python is a scripting language. Now, I have to break down what a scripting language is. It isn't anything. There's no such thing as a scripting language. A scripting language is a programming language that is used to automate behavior in another system. And therein, I've just described the potential of any language that exists. Like, you can do that with anything. It's easier to do it with a language that runs on top of a runtime interpreter. But here's where things get interesting, and I blame Java for this. Because Java has for years said, we're not an interpreted language, we're a compiled language. There's kind of this mincing because, look, compiled language doesn't even really mean anything. Because when you're compiling, all it really means is I'm taking something that's written in one system of tokens, and one lexicon, and I'm moving it to another system. And that happens anytime you move across languages or down to object code. When people typically say compiled, what they really are meaning is assembled, which is that final step you get in C and C++ and what have you, where you take the object code, which itself is not even C or C++ anymore, and you turn it into assembled code. Almost any language is going to hit some form of object or bytecode at some phase. Most languages are compiled in that sense. The only thing that's actually interesting is what stage those instructions become machine code. And there's three ways there. You can have, in what I call an assembled language like C or C++, that assembly, that translation to machine code occurs on the developer's machine or on a build server. And then that machine code is shipped to the end user. In something like Java, that assembly step happens on the end user's machine using the JVM, which is a just-in-time compiler. It's actually a virtual machine, but I'm not going to get into the mechanics. And this is where the Java developers say, well, we're not an interpreted language. But the reality is they're not shipping machine code, they're shipping bytecode. The same thing is true of Python. Most of the time, when you prepare a Python package and you publish it to PyPy, it publishes in two forms, source and binary. And the binary is not machine code, it's object code. It is the byte code. And even if you just run a Python project, you'll see all these PYC files, which are all those bytecode files. So the only interesting thing in Python is, when do we turn that into machine instructions? We can either, in CPython, run it through the interpreter at runtime and run the associated machine instructions, which is when it's an interpreted language, or, as in the case of PyPy, it can run through that just-in-time compiler first, and then it's running as machine code for the whole runtime of the program. But because people don't understand these distinctions, we start getting phrases like interpreted languages are slow, and then we start saying scripting languages are interpreted languages because we use interpreted languages in that capacity. And then from that, we start building all of these assumptions on top of that. It's only good for small projects. You can't really compile it. It's not as fast. And you get all these myths that just spin off of this one misunderstanding in how we actually execute the code in the first place.
Yeah. It feels like, though, in the modern times, and right now we're in 2023, that if you are doing something in a purely interpreted way, the way that we thought about it in the 90s, there's always going to be an option to make it faster. I always use the example of a for loop, and a truly interpreted language goes through a for loop one step at a time. And the second time, it's like a patient with amnesia. And it's like, what? This is the first time I've ever been through this loop. And there's zero, 3 times? They don't even have any concept. There's no optimization at all that's happening. So I really like that example where you're juxtaposing interpreted versus assembled. And that means that term compiled doesn't get overloaded and confusing people.
Absolutely. And I will say, on the point of Python is slow, something I don't even talk about in the book because it happened after I finished it, turned it into the publisher. But Python, 3.11, Python 3.12, we've seen huge performance gains. I read an article that tongue-in-cheek said that if we keep on the current trajectory of performance gains, then 3.14 will be faster than C, which of course is impossible. But the Python's performance has improved dramatically just in the last 2 releases, and a lot of that is owed to Guido's work and the work at Microsoft, and the work that Microsoft has sponsored with internal to Python to really improve the performance of the language. So, and part of that is that they're finding ways to optimize how the interpreter functions and to lend some intelligence to that, that really speeds it up.
We really are at a time when if something is slow, it is very largely your fault, not yours, Jason. But you know what I mean. Like in the C sharp, it's Jason's fault, truly. No, but like in the C sharp community, it's always been a conversation that we are always going to be some amount slower than C. Uh-huh. But in the last couple of releases, just like you said, when people start getting serious, then you bump up kind of like asymptotically approaching C speed, but never really hitting it. The same thing we're seeing now in WebAssembly and in JavaScript, where the same tropes of it's scripted, it's interpreted. Well, yeah, it was, but no longer. This is not your grandmother and your grandfather's Python.
Yeah, and I think the other thing that we're seeing is we can blame the tools less. So like you're saying, we have to blame ourselves more. And that means we're going to be increasingly seeing a return to some fundamental concepts of performance that we've been kind of poo-pooing for the last, 15 or so years. It's like, oh, I don't have to worry about performance. I've got all this memory to burn. And then we wind up with situations like there was for the longest time in Google Chrome, every single time you type a character into the address bar, it completely reallocated the string, which had, if you've done any work with a memory language where you have to do memory management and allocation, that's an expensive operation. You're reallocating every single time. So that is significantly slower than it had to be. And that type of thinking has been very common in the coding world for the last 10, 15 years. It's one that I've always kind of run orthogonally to because it drove me nuts. And I blame the phrase premature optimization is the root of all evil. Mad props to Donald Knuth, incredible guy, but we've kind of taken his statement out of context because, as one person explained it to me, who's to say it's premature? You have to almost be a fortune teller to say it's premature. Now, there's a time to get it working and there's a time to optimize. You should get it working before you optimize it. And when you optimize it, you should be actually measuring it. But it does not hurt to stop and think for 10 seconds while you're building, do I really need to be using this flexibly sized container? Do I really need to be using a double instead of a float? Do I really need to be making these decisions that slow things down when I can make a decision right here that, sure, it's a small gain, but those small gains add up?
Right. And you actually do a great job in the book of these cool little like step aside moments where you'll go, hey, gotcha alert, or hey, I'm going to be pedantic for a second. And I really like the way that you called those out because you have a very clear writing style. But then when you kind of go, you kind of like turn your personality back on. You're like, no, really, don't do that. Like I just said, don't do that. So like I'm reading about pip, the package manager for Python, and you call out that you shouldn't use sudo. You shouldn't run it as admin. And then you kind of like step out of your professional voice. You're like, really? Seriously, don't do that. And then you step back, and it makes the journey quite fun because you call these pedantic notes out. So sometimes when you're reading, as the reader, you're thinking, is he being pedantic here? You literally call it out with a big badge. I'm being pedantic here.
Absolutely. And if there's one adjective that I would use to describe the Python community, it is pedantic.
Hopefully with love and kindness.
It is definitely with love, but this is one of the most detail-oriented, infuriatingly intellectual, but absolutely addictive communities I've ever been a part of. Most of the guys I hang out with in the Python community are a bunch of academic nerds, and I love them. But the conversation, how often it goes meta in the chat room is unbelievable, and we literally digress into some weird hybrid between discussing why we think the way we think and how do we disseminate information. And we're like really going metaphysical on our, someone somewhere has to go, can we come back to Earth now? Like, this is normal in this community.
Well, so let me ask you that though. Is that could be good for people whose brains are wired that way? But if someone's reading this book, maybe they're earlier in their career, they've done some work in JavaScript, they jump into Dead Simple Python, and then you're saying that the guys and gals in Python are a little bit meta and a little bit pedantic. Is that a welcoming community, or is it just that there's different niches and they maybe don't get into the meta chat rooms?
What's nice about Python is that as meta as they are, that meta-ness, I think, has actually, I don't even know that's a word.
Meta-ness? I like it. It's a word now.
I think some of my IRC friends are going, that is not a word. And it's because they're pedantic. Anyway, that has actually led to this being, in my experience, one of the most open and one of the most welcoming communities, because we're really thinking about why are we interacting the way we are and why are we doing things the way they are. I think just as I believe it was Moore's law, I hope I'm not botching which one it is, but I think it was Moore's law that said if you take a 3-part team, you're going to get a 3-pass compiler, that your coding structures are going to mirror the community. But I noticed that this also happens in reverse. No, it's not Moore's law, but I now can't remember.
Moore's law is the one that you double the number of.
I
think you're thinking of Conway's law.
Conway's law. Thank you. I always forget the name of that one. Anyway, but I notice a lot of times language communities are Conway's law running in reverse, and you get the community that fits the language. And Python is extremely introspective. The entire language, like I mentioned, this is Python's thing, is that it knows itself and it knows where it is and what it's doing and why it's doing it. And you can make it do whatever you want if you can leverage that introspection. And the same is true of the community is incredibly introspective as well. And so we're always thinking about how are we interacting, and is that the best way to answer the question, and how are we coming across to this group? And so I think that's produced a community that's very welcoming. You just kind of have to be prepared when you enter into it, that it's kind of gonna at first feel like you're falling down the rabbit hole, because it's like this is a strange bunch of people, but they're people who, for the most part, will absolutely protect you viciously, and will welcome with open arms and just say, "Hey, yeah, cool, you're weird like us. Come build."
Right. Well, once you find your community, as long as you know that it's a safe place, then you can have fun. Now, I know that Python developers talk a lot about Pythonic. Since we're coining words that don't exist, I guess Pythonic is a word. And this is the word that really defines what is something. Is this a good use of the language features, and does it feel right? And they debate this. And this has been debated, since Python kind of started. And I know that Perl thinks about the quote unquote best solution. There has been communities that say there's only one way to do it. There's the one correct way to do it. Is that true in the Python community?
I think Python and Perl very much have the same philosophy. So Perl's philosophy is often abbreviated as TIMTOTI, or there's more than one way to do it. Python's philosophy has been described as I can't even remember that. I can't remember what they call the acronym, but there's only one way to do it. And a few years ago, I wrote an article called "I Think We're All Making the Same Point," and I touch on this in the book too. It's basically, it's two sides of the same coin. So Perl and other TIMTOTI type language communities are very much after finding a better solution. And so by being open-minded, they're always trying to find, okay, if we have 100 solutions to the problem, one of those is going to be novel. One of those is going to be something we haven't seen before, and maybe there's something we can learn from it. So they're always moving towards better solutions because they're not constraining themselves to, you have to fit some sort of invisible standard. Python is doing the same thing, but just kind of a different approach. Because we're very introspective, it's always, there should be one clearly obvious way to do it. And we should be designing the language to help hopefully guide you in that direction, or at least make it click when you get there. But that one way always evolves, and we're always finding better one ways to do it, because we are trying to find an optimal solution, but we want to prove that optimality. And I think both languages try to do that. They're trying to find the optimal solution to that specific problem. The funny thing about that specific problem, whatever it is that it's unique. And so you can find the one right way, either by throwing 100 solutions at it and figuring out which one worked best, or by discussing 100 solutions about it and finding which one you want to say is best. But you're really doing the same thing.
The Python community has a thing called Python enhancement proposals, and there's hundreds of them, and they are suggestions on how we should do things, and they're all proposals that are like, this will make Python better. And one of the fun ones that you publish in the book in its entirety is PEP 20, which is referred to as the Zen of Python, and it's almost like a poem or a haiku, with it's basically this we believe as a community. Do you think that and that was done almost 20 years ago, does that still well reflect the philosophy of the Python community 20 years later?
I would say definitely. I was mentioning it earlier, it's kind of become a bit of a guiding star of the language. And again, in a very sort of tongue-in-cheek way. One of my colleagues is always saying, well, don't take it too seriously. And I said, well, the thing is, in Python, do you ever take anything very seriously? It's the line between kidding and serious for us is very, very thin. And if we're joking, we're probably making a point. And if we're making a point, we're probably joking. And Tim Peters is a master of this. It's like he's very good at making a point in a really humorous and memorable way. And I think this is one such occasion. So it's definitely been a set of guiding principles. Part of the reason we adopted it in a PEP, I think, is because there's no one's come up with anything better yet. It's hard to top. It's so pithy and to the point.
Just as a couple of examples, things like sparse is better than dense. Errors should never pass silently. Explicit is better than implicit. It is pithy. And it's a good example that,
yes,
if you write some Python code, you might want to run it through this almost as a linter of sorts and see if it holds up against some of these things.
Absolutely. And one fun fact about that is if you look at the source code, there's an Easter egg in the Python language called import this. And if you type import this, it will print out the Zen of Python in its entirety. And if you look at the source code, it is deliberately breaking every single one of these rules.
The source code of that import this.
The source code of that import this deliberately breaks every single rule of the Zen of Python. That makes it even more, again, very meta, but it makes it, in my mind, even more effective because it's like, you want to see why this matters. Look at the source code. It's awful. Wouldn't it be better if I followed my own rules? This is kind of how I read this. I do have to mention, though, there is one detail, and welcome to Python, but there's one detail of that Zen of Python that has made one colleague of mine twitch a bit, and that is that there's a space missing after the two dashes in the thing about namespaces. This is left out. There's one space there, and it's missing in the other space. This was in the canonical version of it. So whether that's just a typo that got inadvertently preserved, or whether Tim Peters is just a comic genius, I'm not sure. But again, it's a language named after Monty Python's Flying Circus. So how seriously you take it is kind of, well, how much of a boatload of surprises are you in for?
Well, if you are interested in taking Python seriously, I can recommend Dead Simple Python. You can pick it up at No Starch Press at nostarch.com and check out codemouse92.com to learn all about Jason C McDonald, and of course get a link to the book and all the different places that you can buy it there. Thank you so much, Jason, for chatting with me today.
Thank you. This has been a blast.
This has been another episode of Hanselminus, and we'll see you next week.